And we have yet another problem of the same character, in fact. And the problem is an uncharged metal ball with radius r1. Metal uncharged, this is important. And with radius r1 is touched with another metal ball with radius r2 and charge q2. So its radius is different and it has been charged. So then the second ball is removed at a sufficient large distance after touching. The second ball is removed at a sufficient large distance from the first, that means contact between them broken. And in this case, potential of the second ball turns out to be equal to phi dash 2. That is the potential of the second ball. Normalization is, of course, tends to infinity. That means with respect to infinity, the potential of the balls can be taken as 0. After this, the second ball is again charged with charge q2 and again touches the first, and find the potential of the first ball after repeated the described procedure infinitely many times. So you have to focus on touching, and that means when the balls made contact with each other, since the radii are different, so let of the first contact of the balls, they acquired charge q1 dash and q2 dash. Charge on the first ball as q1 dash and charge on the second ball as q2 dash. It has initially charge equal to q2. So that we can write here one more equation, that q1 dash plus q2 dash will be equal to q2. And we have the value of q2 dash, and q2 dash will be simply 4 pi epsilon naught r2 phi dash 2. That was the potential it acquired after the contact and removed to the infinity. So q2 dash value is here, and we have a relation like this, and we can write something, some relation, some of this nature, like q2 dash by q1 dash. That will be q2 dash divided by q2 minus q1, q2 minus q2 dash. I just framed this relationship from this equation, the principle of conservation of charge, and it's going to be repeated, because when metal balls come into contact, their charge is distributed proportionally to their surface area. So the ratio of charges of the balls after any contact will be same, will have this value, because according to the problem, we are going to get this relation, and after an infinitely large number of contacts, and the transfer of charge from the first ball to the second ball will stop, and therefore we can write a relation like q2 by q1 infinity. That means it has been after the infinite number of contacts when the transferring charges has been stopped, and that will be equal to q2 dash divided by q2 minus q2 dash, and that means we get a relationship like q1 infinity will be q2 by q2 dash minus 1, and we already have the value of q2 dash, and so the potential of the first ball will become phi 1 infinity, and that we can write as 1 by 4 pi epsilon naught q1 infinity by r1, and we can write it as after putting the value of q1 infinity, and we get the values like q2 by 4 pi epsilon naught r1, q2 by 4 pi epsilon naught r2 phi dash 2 minus 1, and after solving you can get a result like this: q2 minus 4 pi epsilon naught r2 phi 2 dash divided by 16 pi square epsilon naught square r1 r2 phi 2 dash, and that's the solution. Thank you for watching this. q2 dash is constant and q2 is constant. That is why I taken this relationship: q2 dash by q1 dash will always be like this, because q2 is constant and q2 dash is constant, because every time it has got to this potential phi 2 dash phi dash 2. So I have taken this relation to be constant and I solved the problem. Thank you very much for